So I changed my mind. I'm not going to do that other example in a video. I'm going to show it to us in class together. So please do that last example by yourself. And we're going to jump into section 4. So we've only been talking about like pretty displays and sort of guessing from graphs, but we could also talk about distributions of variables that are quantitative numerically. So these measures of center, we have 3 measures of center that we're going to use mostly in this class, but there are 4. Those measures of center, mean, median, mode, and mid-range. The mean, you guys already did this in the last knowledge check. Calculate an average. Add everything up, divide by the total number. We do have some summation notation here just to remind us of what this means. So this notation here just says add everything up, starting with the first, going to the last, add them all up. That's all it means. So this is x1, plus x2 plus x3, all the way up to the final x in our data set, divided by the number of things. So the mean, as you already know it. We're not doing anything new or crazy here. Just wanted to get us a little bit more comfortable with that summation notation because we're going to see it in a bit. And just as a note, this little subscript notation, x1, this is talking about the first thing in our data set, the second thing in our data set, the third thing in our data set. So in this case, we'd have all the way up to x6. Finding an average, as we know, super straightforward. Add things up. Divide by the total number of things, right? And you already did this on that knowledge check without me doing it for you. So the only reason I leave this example in, as silly as it is, because I know we all know how to calculate an average or a mean, is because this is getting to that same issue that we saw with that realtor, right? The realtor, when we looked at the mean does its best at balancing the differences, right? So 20 is 5 below, 19 is 6 below, 15 is 10 below. This is all balancing out how far above 80 is from the mean. So that's what you're trying to see in this picture. It's sort of like if we take this, 80 is what, 55 away from 25? I'm just going to count this as 25 because I'm lazy. Whereas 20 is 5 below, 19 is 6 below, 10 below, 14 below, 15 below. This all sort of balances out, right? It's a balancing point. So the big issue is that when we have something that really tips the scales, like this 80 or this value way off to the side, it's going to pull our mean over towards that side of the scale, right? So in this case, 25 is not the best way to talk about the center of this data set because it's way off to the side. And just like we saw with our realtor, saying that he on average sells $2.5 million in homes would probably get him in a bunch of trouble if he used that to budget, because it looked like the majority of houses he sold were under $400,000, which is a miracle in San Diego. So what should we do if that's not the best measure? Well, the median. The median looks at the center position. So we can find the median using the sweep position formula. We also know how to find the median the old school way. We just cross things off on both sides until we find the middle. With really small data sets, this is super obvious, but with larger data sets, it sometimes becomes hard to keep track of this little counting in crap, and it just looks like you're back in middle school. So I have this position formula, and I'm just going to show you how that works. So n is the number of things in our data set, plus 1 over 2. This will tell you exactly where the middle thing is. So you can just count over 1, 2, oops, that's terrible. 1, 2, 3. And with an even number, which you'll see, so this has 6 data points, you'll get 3.5. So 1, 2, 3.5. My median would be there. Remember, if we end up directly between two numbers, you're just going to average them. So 15 plus 19 over 2, 17 would be my median, right? And this looks like a much better measurement if you think about this 80 as potentially being an outlier, some problems, especially with our realtor, to look at in terms of our center. So we got the last 2 measures, the silly ones, that I'll just quickly describe, but these are never going to be the right answer. Mode is the thing that occurs most often in our data set. This is pretty useful in our class only when we're talking about histograms or bin data, right? Then it's useful to look at. Or if we have discrete data with only a few values, like if we were looking at number of siblings, then we might care more about the mode, then we'd care about the mean or the median, because we'd say, oh, the majority of students in this class, or the largest group of students, have one sibling or have two siblings. That would be potentially a useful time to use this, but most of the time, the mode is useless, especially if we're talking about big data sets. The mid-range, I have never seen a reason to use the mid-range. It is literally just the midpoint of the range. So in that previous example, we went from 10 to 80. We're just finding the middle of 10 to 80, which is, oh my God, I can't do this, 45. Couldn't do that off the top of my head. That's exactly 35 away from both of these. What is the usefulness of 45? I have no idea. Never use the mid-range. I just put it here because it's another measure of center that you might see. So which measure should you use? Obviously not the mode or mid-range, but it's all about mean versus median. And this is what I was trying to get you guys to come to with that realtor question without me just telling you what to do. The median is what you want to use if we're dealing with a skewed distribution, right? This is because those are a distribution with outliers. And this is because the mean is going to be problematic. It's going to get pulled towards those outliers, and it's probably going to be unrealistic as a typical value. Now, the mean is great. A lot of you guys gave me the argument that the mean is better because it uses all the data, whereas the median is just the middle value. And I agree with you. But if that middle value is a better measurement of our typical than the mean, we got to use the middle value. So if we have symmetric data, then our mean and median will be fairly similar, but it's better to use one that has more information in it. So that's when we're going to use our mean. And then the last piece, by the way, this is something that will always be tested on. I'm not going to have you calculate a mean or a median. That's too easy. But telling me what to use and why is definitely a test question for this class. Another is how outliers or skew will impact these two values. So as you can see here, what happens when you have something that's skewed to the right is that actually both your mean and your median are going to be pulled slightly to the right of this tallest point, which is our mode, right? But the mean gets pulled more because all these large values are getting added in, and so they're going to make our mean larger. Whereas for the median, we can still get about half of our data, and we're going to be a lot closer to that mode. So I like to make this cute thing into a whale, and then have it like, oops, that's not where this little spout will be. And just a reminder, the mean gets pulled towards the tail, bonus points if you draw a cute little, not really, but bonus points, karma points if you draw a cute little whale on your test when you realize this is what I'm testing you on.